All right, my little pumpernickels, good morning. This is geometry, page 351, lesson 8.2, more on circles. Will they go round in circles? Okay, so if we have a circle, here's the center. What we have today are tangents. Now this word tangent, we're going to use the word tangent and we're going to use the word secant. They do not mean what they meant in Algebra 2. We're not talking about relationships between angles here in the sense of sine, cosine, and tangent. These words have a little bit different meaning, okay? So, it says a tangent is a line in the same plane as the circle that intersects the circle at exactly one point, the point of tangency. A tangent segment is a segment of a tangent line that contains the point of tangency. Okay, so here's my circle. If I have a line that touches this circle at just one point, right there. If it touches this line, touches this circle at this point, this line is tangent to this circle. Okay, this line is tangent to the circle. It touches it at one point right here. What they're talking about, a tangent segment, if this is A and this is B and this is C, segment AB is tangent to circle P at point C. This is the point of tangent C. Okay, segment AB is tangent to circle P at point C. This is the point of tangent C. This is a tangent line, touches at one point. Okay, so that's the first one there. Next one says, if a line is tangent to a circle, then it is perpendicular to a radius drawn from the point of tangency. So we got all the same stuff here. I'm going to move a little C here, put them out here. So we have this tangent line. It touches at point C, circle C. If I do a line from here to there, okay, this is a radius, and it is perpendicular. It is always perpendicular, okay? So it says, if a line is tangent to a circle, then it is perpendicular to a radius drawn to the point of tangency. So I have AB is tangent to point circle P at point C. If I draw a radius from P to C, that is a radius, and it is perpendicular to this. This makes a right angle. Okay, and again, we're going to have right triangles and stuff along with this. Okay, next page, 352. There's a lot of these theorems here. If a line in the plane of a circle is perpendicular to a radius at a point on the circle, then the line is tangent to the circle. So now this is the backwards of it. It says if a line in the plane of a circle is perpendicular to a radius at a point on the circle. So this one's starting in a different place. So I have this. Okay, I have a radius. If I have a line that's perpendicular to this line at this point, if I have this right here, then this line is tangent to this circle at that point. Okay, we went one direction and then we went the other direction. All right. Next one, it says tangent segments from the exterior point on a circle are congruent. This one's kind of cool. This is where we start doing things. Okay, so it says here, we have a circle. I should use this for my center, huh? See how that works? Nah, it's close. So if I have two tangent lines, okay, I have one that's like right here, and I have another tangent line that's right here, like this. It's tangent right here, it's tangent right here. If I wanted to do this, you get it, I can. If I wanted to do this, you get it, I can. These are also equal because they're radiuses. We know that's 90 degrees. Here's what this thing says. If I have these two tangent lines, these two lines are both tangent to the circle, and they cross, they're concurrent right here. This and this are equal distances. Okay, so if I have two lines that are tangent to a circle and they intersect, the two segments formed are congruent. Just for fun, if you do this, you cut those from here to here. Now you have, watch this, you have a triangle. Here's a right triangle. You get this? It's this and this, right triangle. If I know this and this, I can find this distance from here to here. I know bunches of stuff, okay? We turn a little page here. It says a common tangent. All right, this is where it gets fun. Now, y'all get all this? From here to here, those two lines are the same. These two lines are the same, not the same as those two. I should do it differently. I apologize. But if you pull this triangle off, this triangle is congruent to this triangle, and it's a right triangle. We know stuff about a right triangle. Okay? All right, let's try this something else. Now we're going to have more than one circles, okay? So it says a common tangent is a line that is tangent to two coplanar circles. So if I have a circle and I have another circle, these two circles are both in the same plane, meaning they're like this, they're not like this, or some other weirdness like that. They're in the same plane, all right? So what I have here, a common tangent. That would mean a line that touches this one and touches this one, like this. That is a common tangent, yes? This is also a common tangent. Those would be, I think they're called, if I'm not mistaken, just to make sure, those are external tangents because they're outside. Right here, let's see if I can do this because I'm really smart. These are common internal tangents, okay? External tangents, internal tangents. I'm pretty sure. Make sure I read that right. Common internal tangents, yes, because they intersect. Well, actually, if you check this out right here, what they say is, if you draw a line from this center to that center, oh, go figure, these lines cross right there. These are internal tangents, okay? These out here are external tangents. There would be, between this circle and this circle, 4 common tangents. 2 external, 2 internal, okay? Kind of fun? One more thing here, and then I'll show you some more stuff here. Because these tangent things get all sorts of fun, all right? Next one says tangent circles are coplanar circles that are tangent to the same line at the same plane. So now if I have tangent circles, that means that these two circles touch at one spot. These are tangent circles. They have a common tangent right there. This line is tangent to both circles. Do you see that? That line is tangent to both circles right there. Okay, they're externally tangent circles because they're on opposite sides of the line. What if I had another circle like this? This one is tangent also right there, but this is internally tangent. If this is A, B, and C. A and C are internally tangent circles. A and B are externally tangent circles. C and B are externally tangent circles. This is the point of tangency. This is the common tangent. Okay? Okay. If you look at 11 through 14, I guess, there's 1, 2, 3, 4, 5 sets of circles. Do you see that? There's A, there's B, there's C, there's D, and there's E. All little things. They're going to ask questions about those circles and the tangent lines shown. Okay? Name the common internal tangents in figures A and B. On A and B, on A, name the common internal tangents in both figures A and B. All right, so for the common internal tangent on A, it would be line A and line D. You see those little letters on the line? Line A and line D are internal tangents. Line B and line C are external tangents. Okay, on B, okay, it says, are there any internal tangents there? The answer is no, there are not. Okay, so all there is this A and B are the 2 internal tangents. Okay, so you just have to choose what you get. Now 16, 16 gets to be a lot more fun. I'm going to let you play with that and see what you can do. Understand that that is 4 circles. They're just not showing all of them. And the other one is 4 circles. Okay, the ones that overlap are called like a 4-leaf clover. Okay, and It's used in Gothic architecture anyway. So what they're going to ask you to do is to draw all the internal tangents, all the external tangents, how many of them there are, blah, 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 on each of those, okay? It's a lot of fun, sort of, okay? Have fun with that.